So they make a hell of a lot of services, but the original service they produced was allowing customers to buy flights from their home using the internet, rather than having to go through a travel broker all the time, which dramatically reduced the cost of aircraft travel. So that's the examples. Now it's time for you to give me some solutions. You've got a scenario here where you and your teams, so make sure you're in teams. If you're on your own, try join someone else. You have been developing and selling microwave ovens for many years and are steadily seeing profits fall due to increased competition. How could you add a service dimension to your business, and what market segment would you target? So you've got 5 minutes in your teams now. Try and come up with a solution for me. Okay. So if you could stop discussing for a moment. Does any team think they have a good solution that they'd like to share? Otherwise I'm going to go ahead then.
It's like a fizzy drink machine, but it's like microwave food. You press the button and it goes to the microwave and bang, you have a...
Where does the food come from?
It's like the coffee machine. We're refilling the machine all the time. So.
Okay, so you can select the pie and then it heats it up for you and then you get your food. So it's like turning a microwave into a vending machine. Okay, good idea. Anybody else? Go ahead. That's not a bad idea. So maybe rather than making your own product range, they could go in partnership with somebody who specializes in microwave goods. Yeah, good point. Any others? Go ahead. Okay, so that's the promotion of your microwaves through a Top Chef. Any others? Go on.
We also had a crazy idea that the microwave should be connected to everything else, so that if you're watching TV, the microwave knows what show you're watching, and it detects when you're coming to a commercial break, heats up your popcorn.
Yeah, okay, that's interesting. But the nice thing is you're thinking about the use case of the user and its situation. When I did this earlier, there was a couple of good ideas about using this for catering ovens. So perhaps at a university like this or in a supermarket, you might want to lease out high-grade microwaves where you provide a cleaning service for it, and you make sure it's all working and completely safe to regulation for places like a university or a supermarket where they can buy the goods and heat it up straight away. So there's other service models around this as well. Now, just to give you a little bit more theory around service design, there are different strategies. And starting from a pure product area where you just develop a product and sell it, the next stage is the Dewhurst is saying, we are providing services to service the product. So we make sure the product is working. The next lever is supportability. So can we support the customer in using the product? So can we make sure they're using it to its full extent or better use it or use it properly? And the final design for service or of services is thinking about extra services you can add around the product use. So there are 3 levels which you can provide these services. And I think value is potentially increasing in this dimension. Now here's a little method I'm going to give you, and this will hopefully be able to help you apply it to your own products or businesses. So we suggest at the Technical University of Denmark, my colleagues, you start off with mapping out all of the phases of a product. You then map out the user's activities. So if we're to map out the projector, at some point the raw materials are extracted, maybe the electronics is assembled in one country and the plastic casing is manufactured in another. It comes together to assembly in South Korea. It's then transported to a point of distribution, maybe in your local Samsung shop. It's then sold to a customer. Then the customer goes home and installs it and then starts using it. Now the use phase is perhaps before I'm using it, I think, well, it's turned off. I need to find out where the control is for me to turn it on. So I find the control, I turn it on. Perhaps before I use it, I have to plug it in and make sure the plug is connected to the projector. I then go through its use phase, so it then starts projecting onto the board, and I need to move out of the way of the spotlight. I need to make sure my program is uploaded and it's changing my slides and it's the right input. And then afterwards, post-use, I turn it off, I let it cool down, maybe I store it somewhere. Now the idea and the reason to do this is because at every single one of these stages, there is an opportunity to provide a new service, or there is an opportunity to reinvent the product. So we could say, okay, instead of buying from a shop, our local Samsung dealer, can we buy direct? Can we buy the closest provider or manufacturer of overhead projectors? During its use phase, can we start its cool down when the device is stationary? So maybe it goes onto a sort of standby mode when it's lingering on one slide too long. Could help the cool down process. So every single one of these is a possibility to produce a service and to reinvent your product. Now, sun cream. Now, if we think about sun cream, the product is the cream itself. So now what I want you to do in your groups, and then we'll discuss afterwards, is think about the product in terms of its product life cycle. Where is the cream produced? Where does it go to? And so on and so on. And then when it gets to the user, how does the user interact with the sun cream? Or its use phases? So I'm going to give you about 3 minutes just to do a quick sketch in your groups of what you think the life cycle phases are, and then the activities of the customer are related to sun cream. Okay, I think we'll try and do the rest of this in plenum now. So maybe you can help me out a little bit with this. What's the first thing that happens in terms of the product's life cycle? Can anyone suggest one of these early stages? Gathering the ingredients, yeah, exactly. And what would be the next stage? Producing the cream. And what do you think you have to have decided at this point? Exactly. So you should have decided on its viscosity at this point. And what else do you need to decide? Its smell. Say again. Production location. Good point. Color. Packaging. Well, I guess that would be at the next stage where you put the cream into the assembly line. So that cream, you made all those design decisions about the cream. It then gets transported to a bottling line where you decide, what do you decide at that point? Yeah, what the package, what size, yeah, design, what this basically looks like. So then you fill the product into the packaging, the bottle, and then what happens? Transported to the warehouses, and where does it get sold to then? To the retailer, so probably somebody buys it. So that's the point now where the user comes in. So think about the user now. When does the user decide to go and get the sun cream? When it's sunny? No. When then?
When they're afraid of getting skin cancer, I guess.
Okay.
Before vacation.
Before vacation, that's an important one. And what's one of the activities they do before vacation, before they go and buy it? Research? Yeah. Say again? The plane tickets, yeah, but with regards to the sun cream. So one of the things they'll do is they'll check, do I have any cream left in my cupboard? Is the cream in date? Is it the right sun protection factor for what I want? So maybe when they've decided that, then go ahead.
Just before going on the airplane, because if you have to throw things away.
Yeah, interesting. Well, there is a lot of sun cream sold at airports on the departure side. That's a good point. But let's assume it's not done at the airports. Some of the things you have to decide are, have you got any cream in your house that satisfies your requirements? You then maybe have to think, okay, am I going to the supermarket? I don't want to take a trip there just to get this. But maybe when am I next going veg shopping? Okay, I can get it on Thursday. Remember to get this item. So then you get to the supermarket, and then what happens? You may forget it. But let's assume you stumble across the sun cream aisle now and you see these creams. Then, yeah, so you have to make a choice. Which one do you go for? The best design. But how do you choose which is going to be the right product for you at that point? The factor. And what do we base, and the price? And the size of the bottle. So these are all decisions we have to make, not really knowing when we're going to actually use this product. So we have to guess all these, thinking maybe sometime in the next few years in Britain it might be sunny. So then once we've got it, we make a decision, we say we want this one, we stick it in our shopping trolley, we get to the counter, we buy it. What happens next? What does the user do next? Well, exactly. He takes it home, puts it in storage, and then what? Forgets it. He could forget it, and that seems to be a reoccurring theme. And if he didn't forget it, or she, when would they decide to take it out the cupboard? On a sunny day. So they wake up in the morning and they have to think it's a sunny day outside or it's going to be sunny later. And then they take it out. And then they go to the beach. Or packing the suitcase for the trip. But all of these things are preemptive. They're thinking down in the future of when we're going to need it. So I think, okay, I'm going to the beach later. I put this thing in my pocket. No, actually, I have to bring a bag because it doesn't fit in my pocket. So I'm going to bring a bag instead. And then I go to the beach. And then maybe eventually I have to make another decision, which is... Yeah, okay. Too late now. I can't go in the sea anymore. That's done for. So what do I do next? I get to the beach. I have this in my bag. It's a hot day. Right? Yeah, if you're lucky. So maybe there's parts you can apply it to, but there's parts you can't reach. So one of the activities is applying it. What else does the user worry about at this stage? Have they covered themselves enough, completely? Is there equal application? Has somebody drawn a rude part on my back because I've asked my friend to put it on me? Lots of things, lots of problems, and all of these things are potential for new product innovations or new services. So then after we've used the product, it gets sand in the cap, and it's annoying, and it's dirty, and my hands are greasy. I then put it in the bag. Maybe I have to reapply later, but I'm not sure. Maybe I can get home in time before burning, before having to reapply. I don't know, I have to make this decision. And then eventually I get home, and I put this in the cupboard and I store it away for the next time I need it. But think about all of those activities and the actual bit that's providing value. So all of those things that the user has to do, and all they want is coverage from the sun. So now I'd just like you to spend a couple of minutes thinking about a new solution. All of those activities and all these stages of the life cycle, where could you provide a service or a new business opportunity? How could you reconfigure this to be a better solution? So just discuss quickly in your groups. Okay. So now I'd like to hear your latest sun care innovations. Go ahead. Okay, that's a really good idea to help the use and application.
We had basically the same thing, but it's connected to the internet. So that, for example, it tells by the time of day, it's not useful to apply a high UV factor in the evening, for example, and so on.
So perhaps not necessarily connected to the internet, but some kind of intelligent service to decide, make decisions based on the weather conditions, what the application should be.
Are you working remote or maybe you on a holiday and then you know that you have to use, when you wake up at 8 o'clock that you have to put some cream on or reminder. It's a holiday season for
Yeah.
everyone and you don't have any business meetings on that day or whatsoever.
I understood that as a scenario. I didn't see. Sorry, I didn't hear your idea.
You have a mobile app,
Yeah.
like basically, and then it knows from calendar that whether it's
Okay.
or you are on a holiday, and then what is your location and what is the weather forecast and so on.
That's not a bad idea, actually. Remember to, and you could synchronize that data quite easily, probably. Yeah.
It's like, or maybe Google buys it and then adds it to your like Google car.
Yeah, it's okay. It's a good idea. Any others? Go there. Sorry, we'll come back to you in a second. That's very innovative. Well, actually, I believe, I don't know how I know this, but makeup, cosmetics actually has, I think some foundations have SPS factor into. Oh, really? Okay. But yeah, shower cream, even better.
There's also one fun part where you could, you have these people who are selling ice cream at the beach, but you could also have like very sexy men and women masseuse with the sun care. Like they are applying the cream on the end.
Bloody good idea. I really like that one. And last one? Sun cream buddies. Yeah. Okay. Interesting. Okay. clearly there's a whole wealth of services you can provide here, but also visualizing your product in this way helps you think about how you can reconfigure this to be something completely different. Now, the solution we came up with, this is a product which I was developing in the UK, was simple small sachets of sun cream which are installed. Is that your solution? Oh, well done. And this is the wrong solution. No. So basically, this was a product to be sold and installed within ice cream vans. So the idea would be we'd sell this in bulk to ice cream producers who would then distribute it through their own supply chains to all these remote areas and beaches around the country, so that whenever you go to the beach, you don't need to use your own sun cream. It's there. You go to the ice cream van and you buy a single serving, and then you don't need to carry anything, you don't need to take anything back with you. It's just at the point you need the service. So that was the solution we came up with. So we made some different transportation system going through current supply lines, use at the point that it's needed, and eliminated a load of the unnecessary decision making that was required in current sun care. And also, at the time, you may choose a completely different sun protection factor compared to what you would have chose several weeks ago in the supermarket. So that was our solution.
Is it in production?
No, it's not, because basically it got to this stage. I had 2 client meetings, and then I moved to Denmark, where there really is no sun. So this is currently with a colleague in the UK and stationary. But if anyone wants to develop it, you've got my blessing, and I'd support you. But yeah, it's dormant at the moment. So to sum it up, PSS can be an effective way to bring suppliers closer to the customers while responding more to the customer's real needs. Service should be integrated into the design of products where valuable. So think about how you can add services to your product. And hopefully we should be able to avoid situations like this by thinking about the use case of the product in its situation. I also noticed there's, just in that corridor over there's a condom vending machine. I wonder who thought that was the place where you think, oh yeah, okay. But, okay, no time for questions there. We've got to move straight on, I'm afraid. Oh no, actually we need to change presentation. Is there a hard deadline, by the way? At 8 o'clock?
I understand it's hard for you because you have to leave.
Oh yeah, that's a good point, actually. I forgot. Yeah. Okay, yeah, good point. I better hurry up. Okay, so you've seen all that. Now we're on to, we've done integrated product development, product service systems. Now we're on to open design or open source design. This is a particular academic sort of hobby and interest of mine. So what is open design or open source design? Well, if you look into the Oxford English Dictionary, you won't find the definition of this. But if you look at the Oxford English Dictionary, you'll find a good example. So when this was created, they actually had academics and enthusiasts of the English language to post in comment slips with words and definitions which could be then entered into the dictionary. So this huge Bible of English words was basically crowdsourced through academics throughout the world, or throughout Britain at least. So for this presentation, I'm going to split open design into 2 categories. Firstly, crowdsourcing and open source design. And just so I get a feel, can you raise your hands if you've heard of crowdsourcing before? Okay, not as many as I thought. And open source design, well, we'll come to in a minute, but it's probably not as popular. So crowdsourcing is basically, there is a large community out there who are willing to do fragments of work for you for a small fee or for other kinds of, and these are basically organized around web platforms into several categories. Now there are crowdfunding websites, and these websites are basically where you can get funding for your project or your ventures. So you guys If you don't win this competition and get some money, you can decide to put your project on a crowdfunding website and get people to give you some money to start up. There's labor, where people do some work for you, crowd innovation, where they do the design for you, and creativity, where they do branding and aesthetics. Distributed knowledge is things like Wikipedia, and there are also some crowdsourcing tools. So why would we use it? Well, there's a nice case. One of my colleagues at DTU, working for a consultancy called IPU, developed this really neat dynamo for bike lights. A really, really simple design. It's just a coil in there with a magnet passing past the light, and it activates the light each time it passed. Now, he produced a patent for it, and then he sold the patent to an investor. Now, this is a pretty small and simple product, so it's almost a little bit frustrating that he couldn't go the extra distance and commercialize it, make it for himself, produce a business from it. Why did he have to sell it to an investor? So I asked him, and he said, well, the typical problems: I didn't have the money to start it up, I didn't have the time, and I don't think I had all of the expertise to develop this. These are three things that you can now achieve through crowdsourcing. So firstly, he could choose a crowdsourcing website, and the most popular ones are Kickstarter and Indiegogo. And if you haven't been on these, I suggest the first thing you do tonight or tomorrow is go check these out. It's very important. And you can put your project on. It's got very simple guidelines. It's not difficult to register a project. It's got a few submission pages where you submit your proposal, what it's about, what category it's in, how much money you need to raise. And then very important thing is the rewards section. So your product page will look something like this. And this is a project somebody started up saying, we want to develop this, which is an iPen, a stylus to work with iPads. And they said, we want your money to bring this to market. Now, what incentivizes, so I go onto this website and I see currently 336 people have given them money. They've raised 21,000 of the 35,000 required, and there's 24 days left to go. If I click this button here, it means I'm going to donate to this project. Why do I donate to it? Well, they have different reward schemes, so they lay them out, which might be, give me $1 and you go onto our official mailing list. Give us $20 and you are invited to the launch party. Give us $30 and we'll give you one of the first edition batches of this product. Give us $100 and you get named on the packaging of the material. Give us $1,000, you get naming rights for the device, and so on. There's various incentive schemes. And projects are really getting funded and starting up through this. And the beauty is, as entrepreneurs, you don't have to go through this valley of death where you have to take loan money out and then pay it back through its initial startup. You get the money up front. Now we've got the money, now we need to develop the product. We can use a load of different crowd innovation sites. Typical one here is Quirky. And they have a simple process by which you can manage your product development. So you submit an idea, the community look at it, then meaning every person who's on Quirky can look at your idea and say, do we think it's a good idea or not? Would we like to see it taken further? If it gets enough interest, the Quirky team evaluate it. They go through research and development with the community of designers. So they organize the crowd for you. Design, develop, and brand the product. They then help with the engineering and finalization. We reach the threshold, and then Quirky organize the manufacture of the product for you. Now, of course, they take a cut of your products, but basically it's a development team around you that can help you guide this product through to its final manufacture. So here are some typical inputs from the community at the concept level. You could say, I need something installed in a microwave so that the product is stirred as it's heated. And these are the typical solutions. It can be some kind of sketch for an idea here. It can be a little mock-up where they've stuck a stirrer onto the top of a microwave. It can be a more elaborate version or prototype, or it can be a 3D model. But you can basically choose or evaluate any one of these for further development. The other sites are crowd labor sites. So this is if you want very simple tasks to do it, and you may not have the time because you're too busy running and expanding your business. You can get someone to do debugging for you. You can get someone to do advertising and testimonials, proofreading, web design, graphic enhancements, surveys, and so on. You can pay people to do these, and it doesn't cost a great deal. These are typical websites you can use. In the summer, the night before the lecture, I just went on, I think it was Fiverr, this website, and just said, please somebody write me for $1 an advert for the European Innovation Academy. The next morning I opened my mailbox and someone had done it. Obviously not hugely high value, but you can get pretty rapid results from it. The other one is that I've used quite a lot of is the aesthetics and branding. I've used this 99 Designs a couple of times, and I was amazed the first time I used it. I think it was $299 I put up. Within 3 days, well, I put up a project description of the brief of my product, what values it's supposed to have, what I want the product to be like, and what the logo should reflect. Within 3 days, I had about 70 different proposals for new designs for logos, all good quality. But the nice thing about the process is, as the first few designs come in, I can evaluate them real time to say, I don't like that one, I don't like that, I really like this one. Then the community responds to my feedback saying, okay, forget those two, the style that is in. Let's focus on this style because he seems to really like this. So you sort of guide the community through a process to produce better designs for you. After 3 days, you choose your best 1 to 5 people to develop the designs further, and they just produce them further up to the standard you want them. You can ask them to do it. I'd like to see it on a bottle, so they give you a graphic of it on a bottle. I'd like to see it on a website. Choose your winner, do that. And the winner gets the $299. In response, they sign over the copyright of the logo or website to you. Here are some typical logos for what was a human lie detector product. So this was the winner selected, but they're all reasonably good quality. And the nice thing is about crowdsourcing is there are crowdsourcing sites for virtually every phase of the product development process. So of course you need to organize it and guide it, but there is help for you. You don't necessarily need to have legal departments and branding and web support, because you can get quite a lot of it from the crowd. And I would say there is now a mature field, so I would say start using it and start mastering it. Now the other area that I'm interested in is open source design. So we have open source software movement, which I'm sure you've all heard of, but I'm particularly interested in the parallel, which is open source hardware. So for open source software, we share or we make open the source code of the product. So can anyone suggest for open source hardware, what do we make available? Sorry? The CAD files. Sorry? Well, you could make the patents open. You could relinquish the patents. But generally speaking, if you've got the patents, you keep them. But otherwise, you go open source and you make the CAD files, the assembly instructions, the instructions to make these products available to everybody. So to develop this a bit further, you have the open source software community, Firefox, Linux, Android, and so on. Then there are hardware products, which are Adafruit, OpenIDEO, Architecture for Humanity. And then there is a couple of overlaps, which are hardware products with software elements to them. And these are the bits that I'm interested in. So why would we want to not protect our design and share it with everyone? Why do we make it open source? Well, there's a few good reasons, I think. One is to fund research and development instead of legal fees. One is to maximize the value of the product so that people can start engaging with the product while it's being developed rather than only at its final stage. And the third one is to spend less time trying to block the development of others and more trying to be gain value from being visible and influential. There are a few licenses that can help you get some, basically lever some value from your open designs, and basically they suggest anybody who uses the open design has to credit you in some way. So if you look, my slides here have a Creative Commons license on it, which means basically any of you can go and deliver my lectures, and you can get paid for it if you like, if people think it's interesting enough, and you're okay to do it, as long as you have this line on the bottom. And if you make any changes to my material, the important thing is you have to also release it as open source. So you can't make a few changes and then copyright it. You have to, based on this license, also be open source. Now, I would say it's definitely not an established field. It's an emerging paradigm and a gift to the people and society. A good example is this Braden lab in Harvard doing some drug development. Normally, to develop and launch a drug, it takes about 10 years, in which case they're trying to patent it and also produce the clinical trials. But the Braden lab came up with this really good enzyme inhibitor for fighting cancer and decided to release it straight away. And what happened was they released it open source, and a number of different research groups sprang up using or making derivatives of this base compound to fight different strains of cancer. So while there would be normally a 10-year period of nothing happening, over several years there are drugs developed based on this which are fighting cancer in real time. There are a number of other companies adopting open source strategies. I won't dwell on that. But a couple of very important ones are the Arduino microcontroller. This is an open source design, and the RepRap 3D printer. This is the one sat on my desk in my office in Denmark. And basically, this printer can print digital files into products. Now, why is this such an important thing? Well, one of the nice things about this one is it prints its own parts. So for 400 to 500 euros, I've bought one of these products. Now I can print off a complete set of parts for you and sell them to you for 100 euros, and maybe to you for 100, and you, and you, and you. I've made my money back. You develop your own printers and start making them for your friends, and so on and so on. The only thing you have to do is buy some standard components. Now, why this is an enabler for open source design is because there's a thing called Thingiverse. Now, Thingiverse is a platform where if I create a new digital design, I can upload it to this platform, and it might be a new mechatronics hand. I can upload the design files, someone can download them and print them using their RepRap printer. So all of a sudden, we don't have the normal distribution channels. We just transfer electronic files to each other and start printing off our own products. The Copenhagen version of this was the Free Beer project. Now, basically, somebody produced a really nice brew of beer and decided, I'm going to make this available to everyone. They produced a complete ingredients list and instructions for how to brew free beer and said, if you want to brew it, you can put our label on it and you can sell it. So that's exactly what people did. They got loads of people who are producing it and selling it, but also people were making different varieties of it. So a group in Taiwan here produced Free Beer 2.5, which is a version in Taiwan. Another group produced a ginger-based variety of Free Beer 4.0. And these can all make this, put this label on and produce it themselves. Now there is a slight problem with this, of course. Free Beer make their money through their brand image. Can anyone tell me what the problems might be here for the company making Free Beer, or the behind the brand of Free Beer? Shitty quality, exactly. Yeah. So you basically can produce this beer, and it could be a very good quality, but you can have one person who's making a terrible batch of it, puts your label on it, and all of a sudden the first time somebody tastes free beer, they think it's bloody awful, so they never try it again. So open source has some quality control issues, but there are clever ways around it. As Deb said before, it's an emerging paradigm, a gift to society, but can we really make money from giving things away for free? Well, I think we can. Here's a really good example. This microcontroller Arduino. Now they made this completely open source. They tell everybody, here is how to make our microcontroller. So that's exactly what people do. There are companies just producing complete replicas of this and selling them. But if they sell them, they have to be quality control checked by Arduino if they want to use their trademarked logo. So I can buy this on the internet, but I'm not sure if I trust it because I don't really know who's made it. Now, other manufacturers can say, well, we're making this, we know it's good quality, and they license off the Arduino brand to put on their products. So Arduino make license fees for every time their logo is used on another product. So they actually make money through this. Furthermore, with Arduino, they are a huge company now in terms of worldwide distribution, but have not spent a single penny on advertising. So everybody knows about Arduino who works in the microcontroller industry or hack-it-yourself electronics, but they haven't spent a penny on it. Because it's open source, because people hack it, they advertise it for them. So just to relate it to the integrated product development model we saw earlier, we see the traditional route, but also in open design, the developers of the products could also be the users. So what we have in open design is expert users who use the product, who suggest changes, who actually go in and make changes and upload the changes. So the users are real enthusiasts involved in the development activity. Now, we did some work looking at open source companies and seeing how they structure their business plans, and we realized that they basically had identical business plans apart from the revenue streams area. And the revenue streams they made were either from sale of expertise, so they become very well known for the free beer project or whatever, and then they do some consulting based on it. They produce spin-off products based on this original idea. They have straight production, so Arduino can make the Arduino boards, and when I think about Arduino, I go straight to their website. I don't go to any of the other suppliers of Arduino, I go right to them. So they make money through straight production, also through advertising and licensing, value from the use phase and users' data. And some of the benefits of open source are rapid and cheap publicity, multi-user development expert customers, increased product varieties, meaning you put one out there, people create different versions for you. It's a bit of a competition killer because it's hard to compete with something that's free. And suboptimal is forgivable, meaning if there's some problems with the product, it doesn't necessarily kill it. They're willing to accept that because it's open source. And here's David Cotillas, one of the founders of Arduino, saying, right now, being open is no longer an added value. Either you're open or you're out. The internet has changed the game. We're becoming self-producers with access to information and possibility to learn whatever, whenever, wherever. And to a certain extent, I believe that. Would you mind, Thomas? Thanks. This is a particular project, open source, that I found very interesting.
Ever since we made it easy to make your own balloon maps during the Gulf oil spill, we in the public lab community have been working on new ways to detect, quantify, and investigate environmental contamination. We want to be able to prove whether a given patch of brown goo is in fact crude, motor oil, or just mud.
One common technique to identify an unknown substance is spectrometry, which measures the colors absorbed by a material. Light passes through a sample, and some colors are absorbed. A prism splits the colors so that each can be measured separately. If you graph the brightness of each color...
Okay, turn that off. Round of applause for Thomas. No, don't worry, turn it off.
Since we made it easy to make your own balloon maps during the Gulf oil spill, we in the public lab community have been working on new ways to detect, quantify, and investigate environmental contamination. We want to be able to prove whether a given patch of brown goo is in fact crude, motor oil, or just mud.
One common technique to identify an unknown substance is spectrometry, which measures the colors absorbed by a material. Light passes through a sample, and some colors are absorbed. A prism splits the colors so that each can be measured separately. If you graph the brightness of each color, like the EQ on a stereo, the resulting spectrum is like a fingerprint for that material. Unfortunately, spectrometers turns out it has a bluing agent to make the whites look whiter.
Okay.
How can you get involved? We're looking for people to help test and refine these open source techniques and tools. So get a kit or build one yourself and start collecting samples.
Okay, why have I played this particular video? Well, previously I think the way open source products are created in the hardware is, well, we've created a product, we don't want to commercialize it, so let's make it open source. Whereas this product is actually thinking about it right from the beginning. How do we make money from being open source? Now, I don't know whether you heard, but the term Shazam mentioned. There is an app called Shazam, where if you hear a song, you can click the app button, it listens to the song, it then matches the frequency it's hearing to its database of frequencies, and then tells you what song. They basically thought, well, we'll do the same thing for spectrometry. So when we upload our spectra, and we tell what sample it is, then when somebody else uploads a similar spectra, it can then go onto the database and match it and tell the person what this sample probably is or contains within it. So they're giving away the hardware, but thinking, well, let's make money from creating a database. Because we can make this cheap and available for everyone, they'll start populating and supporting this, and we'll make money through the data. Very ingenious, clever way to produce your business model, but really open source hardware at the root of it. And as well, I just noticed a few days ago, 18th of January 2013, Nokia backs 3D printing for mobile phone cases. So now, mobile phone cases from Nokia, the design is going to be released onto the internet, the CAD files. So we can start taking them, manipulating them, and making our own versions based on their CAD files. And they're actively asking us to do it. So I think open source design and hardware is going to become more and more popular. So maybe if you have the opportunity, you might be one of the people riding the crest of that wave. I have one more section of the presentation, but while we're uploading, do we have any questions related to crowdsourcing or open source design? Nope. Do we have some more slides? Good. So this final section, we're running 10 minutes behind, is on protovation. In other words, how you can prototype your business idea in terms of its technical capabilities and its market. So again, we can look at the three areas of product development, but the first thing we should ask is, where are the big question marks over our business? Is it on the market level in terms of, do the users want it? Or is it, will they actually pay that much for it? Is the market really that big? Does the product work? Does it look good? On the production level, does it have the desired properties from the production we need? Can it be produced at that cost for that volume of production? Now, we have a number of different question marks over our projects. The thing to do is think, where are the biggest question marks? Because the point of prototyping isn't just to prototype. It's to test or validate something. So what you should be doing is producing your prototype to deal with the big questions. Here's a project which won the Venture Cup competition in Denmark, which is a centrifuge for people in rural areas in South America who collect gold to separate the mercury from the gold. And it's basically a hand-winched centrifuge. So they went to the Venture Cup, and before they did that, they knew they had a big question mark, which people would ask. I mean, they could see the value for the end users. They could see the value for the environment. They knew how they'd get funding for this. But the big question is, can they produce enough force from a hand crank to produce a centrifuge to separate mercury and gold? Now, they didn't quite have time to produce the prototype for this, so they went to the next best thing, which was contact a professor at MIT to say, they gave him the requirements and said, could this be theoretically possible? And he wrote a statement for the company suggesting, yes, I believe it's completely theoretically possible to do this with the forces you have available. So it may seem weak, but this is enough for an investor to think, okay, based on this, I'm happy to put a bit more money into investigating whether this can really be a reality. But at least they made some attempts to deal with this critical question. Another project from my course was this wind share device. They made a very simple wind reader, which has two magnets in which the smartphone can pick up the frequency of the magnet spinning round, and it can actually measure wind speed at the particular area. And then what happens, it finds out your geographic location and uploads the wind speed onto a website. So kiteboarding, windsurfing enthusiasts can find out what the current wind speeds are around the coastline based on what your expertise level is, or maybe you just want to find out where the most wind is at the time. So this was the project they developed, and they basically said, well, we can produce this for extremely cheap, but it has definite commercial potential in the Christmas markets. You know, my grandmother might think, Tom, he really likes windsurfing. Yeah, this wind reader, £30, that's okay, I'll buy that for him. So it really had potential at Christmas. But their big question was, will people actually upload their wind speeds? So they can give these products away. They're very cheap. They could give them to a certain number of users and said, can you trial this for a period for us? Just by giving it away. And by doing that, they were prototyping their market to see, will people actually upload their wind speeds, even if they're given the product? In a magazine article I read, it was a number of listing 10 social innovations, and this was one of them which made me laugh, which was these hand supports on public transports, and a company was producing some digital games in these hand supports. Now, what do you think the big question in this business model is? Where the money lies. Meaning, who's going to pay for that service to be installed? Exactly. I can't really think of a way where the transport system is going to purchase these things. I actually don't think the users will use it either, but I really don't see the incentive for the transport services to buy it. So the first thing this company has to do is prove that they can get a contract from these people for one reason or another. Now, I would say when you're looking at your business model and how your business is developing, there should be two fundamental alarm bells in my experience. Firstly, if the system requires a full rollout to be of any use to the customers or stakeholders, meaning if you can't roll out a part of your business and make value from a part of it and then slowly start rolling out other elements, you could be in trouble. If it requires you to put all the upfront investment to install the entire system, you could be, as I say, in trouble. And the other alarm bell should be, if you cannot think, you may decide that lots of people might want to buy your product. If you cannot find the single person who would definitely buy your product, then alarm bell should also ring. Now, could you just play the video here? This is a company called Better Place, based in Denmark.
We don't want to put an end to this, or this, or even this. We just want to end the world's dependency on this, because it causes this.
The increase in the cost of a barrel of oil dramatic. Experts say the rising temperatures are proof of global warming.
Which is why we believe this.
We have to make the right moral decision. We have to make it immediately.
So we're making the world's first electric car network. It's made up of hundreds of battery switch stations, where you can switch this for this in less than 5 minutes. We call it Drive, Switch, Go. We're also building thousands of charge spots that look like this, so you can recharge at home, at work, or wherever else you stop. All this means you have all of this, everything you'd expect from this, and none of this. And no worries about this. The side effect? You help save this. This is Better Place.
Okay, so Better Place have gone through a number of rounds of huge investment from government sources. Can anyone give me a reason why they have a particularly challenging business model?
Not enough clients, not enough cars, the availability.
There's not enough car producers with this battery technology, is that the point? Yeah, that's one of the reasons. Anyone else suggest a reason?
Wherever they're putting their machines, so actually they need to pay rent from the landowner.
That's true.
Infrastructure is quite costly.
Say that one more time.
Infrastructure costs quite a lot.
I think that's the fundamental problem. I don't want to buy one of these cars until I know the infrastructure is in place. So we need charge points and battery replacement points all over the country before I want to buy one of these cars. Furthermore, we need complete standardization. So I need to know that all the car producers will subscribe to a single battery type so that the costs will drive down. So all of this needs to be completely in place, all of the cars, all of the batteries, all of the service stations before anyone wants to invest and buy a single car. So that is a big challenge for the Better Place business model. And if you find yourself in a situation like this, then obviously alarm bells should ring. Now, of course, I think they might make it, but they have to have huge, huge upfront investment to make it. And of course, it is for the good of society, so I really hope they do. Okay, I think we'll skip this little task here and go to one at the end. But I'm just going to give you a couple of examples of the types of prototypes you can produce for your products. So basically, a prototype is a model to test an aspect of the product's feasibility dealing with one of those burning questions identified earlier. There are a number of different types of technical prototypes, from proof of principle, form study, user experience, visual, and functional prototypes. In terms of proof of principle, basically this is a prototype which can tell you about something about the workings of the design, and usually it's used to find out which design options will not work. So Dyson, legendary, had 5,127 prototypes before developing his first vacuum cleaner. All proof of principle prototypes trying to make it work better. And if you go to the Dyson R&D factory near Bath, you basically walk into this corridor and it's full of all his past prototypes. So he really makes a virtue of this fact. And every of his prototypes of his new products have 550 different tests applied to them, from kicking it down a metal stairway to taking one out of a bin and smacking it with a hammer of every 100th bin. So he still has testing for all of his prototypes produced. There are form study prototypes, and these form studies give you some kind of look and feel for how a product should be. Here's a cutting tool and a simple prototype. It doesn't need to be able to cut anything, it's just how it feels in your hand. Here's another Dyson product where they can produce a foam model which they can stick on a wall to decide, is it intuitive enough for somebody to raise their hands in and out of this dryer? Do we need it horizontally? Do we need it at an angle? So they can, before making any technology, they can make some design decisions based on a simple foam model. A user experience prototype, well, if it's on my laptop, there's a little video to go with this, but this is me sat at one of our prototypes where there was a project trying to say, can pilots fly planes just by using digital displays? So without using any physical controls, just LCD displays. And we thought, okay, well, that's interesting. So if we did that, could we have the LCD display down where the normal control stick is? And if we did, could we have some kind of notification on the screen in front of us what we're touching and where our hand is? Would that be intuitive enough? So we just had a very simple mock-up where we could evaluate, is it intuitive enough? Or does it have to be all the touchscreen right in front of your face? Or do you have to be able to look down at the touchscreen to your side? So this was a simple user experience prototype. There's also the visual prototypes, which the car industry use particularly well. is the box-like Volvo and the beautiful BMW. And then the functional prototypes are the last-ditch prototype. This is the final ready-to-production model. So this is the version that you should see when it comes out the production line. And this is just for all the last-minute testing to see whether there's any problems you didn't realize beforehand. There was a case study in the UK called the Advanced Passenger Train, and they actually produced a prototype vehicle to test any flaws, but they thought it worked okay, so let's release it and put passengers on it. And it was a huge failure, and they basically closed the project down based on the failures of this prototype being used with passengers, because prototypes are supposed to be used for testing, not for real production. Yeah, I think we've got time for one more.
You two are a couple of schmucks, you know that? This looks like an 8th grade science experiment, this thing. That's what it looks like.
No, it's going to be.
What is it gonna be?
It's going to be an antenna with a camera attached, and you'll see it on the screen in the front.
Yeah, and how much money is that gonna cost?
I don't know.
I don't trust him. We're never gonna get to the party. Look at this. Standstill traffic.
All this. It's causing
I know.
this. Oh, hey! Oh!
All right, you're not going to believe this.
What?
We got a garbage truck at 12 o'clock. You go to your left. Go to your left.
What?
Right?
Seriously?
Go to your
Did
left.
you really see something?
Yeah. Wow.
Oh my God!
Yeah.
I see it.
Okay,
Unbelievable.
so yeah, just get that now.
I'm willing to admit it.
So this is a nice sketch from a show called Curb Your Enthusiasm. It's a terrific comedy show. But basically you see some of the interactions of users using prototypes in this sketch. First of all, Susie says, look at this piece of junk. Is it an 8th grade science project? Which is obviously one of the things you need to design around. You can't let the users, your subjects, evaluate the prototype based on what it looks like. So you have to have a very careful experimental setup so that they are actually evaluating the functionality or what you want to test, not what it looks like. And of course, the idea of this prototype is to produce, see whether it works, it has a real function to it. And of course, in this ludicrous situation, it does. But the real thing's supposed to be an antenna on the front of the car. Can I skip? No. Here's some example prototypes that I've used in the past and learned a lot from. I actually made a design decision before a colleague of mine convinced me, no, let's get them prototype first. And I completely changed my design decision based on a simple proof of principle, rapid prototyped version. The other thing that's important to note is trying to design your product so it is a prototype rather than its final production version. So some of the parts that I had to design were designed like this for mass production, but I had to make simplistic versions which were welded, which were much easier to tool. I could make this in the workshop. I couldn't really make this in the workshop. So you have to slightly adapt your design for your functioning prototype. Here's an example prototype where we had this U bracket here, which links around this part of the lock and is connected on the other side to the painting. Now I realized it worked perfectly fine on a board, but when I went to try and install it on a wall, I realized that sometimes you have wallpaper, and that wallpaper is sometimes a bit spongy, has a thickness. And when you screw this to the wall, it reduces that gap there, and all of a sudden, I couldn't get this this U shape into this gap, and it was scratching down the wallpaper at the back. So just this simple mock-up, I was able to decide this really isn't the right design to go for. So eventually I got to version 9 of the prototype, which is pretty much what we went for in the end, where I moved the mechanical design around so we inserted it from the front rather than sliding in from the top. So I've really experienced the use of prototypes in my design work. Just put this one on for a couple of seconds. that'll do. So this is a really simple paper prototype which you can use to test the navigation of your product. Now, most apps should only have 3 or 4 navigation points, really, to make them easy to use. And you can do this through a paper prototype. You don't have to have the app developed before you send the specifications to the app designer. Make some mistakes on paper first. Why not try something like this? Now, those are the technical prototypes, and I haven't got a great deal of time for this. But we can also do some market prototyping to decide whether the market really want your product. Now, what are the big questions around this sun cream solution that I came up with? What do we think, if you were an investor with a load of money and I'm pitching to you, this is my solution, what do you want to know? Sorry? Do people need it? So how could I prove that? Do people need it? I could just ask people, but maybe people just say, yeah, I think that's a good idea. Do we really know whether they need it just from asking them? Make them pay. So we could go to the beach and say, would you pay money for a sachet of sun cream? So do we need to develop these first? What happens if we went to the beach with a tub of sun cream and said, would you pay 50 cents for a squirt of sun cream? Would that be enough? Maybe we could leave these sachets, something like this, completely empty on the top on the ice cream van, and see how many people are willing to pay for them, but then say, actually, there's nothing in them. Or maybe we could just have some bottles lined up to say, you know, if you want, you can pay 20 cents and you can use one of these, and see if people are actually using it. And we can do these types of things, and we can get evidence without paying a penny on manufacturing and development costs. So let's get some of the design knowledge up front. What else might we need to know about this product before investing in it? Who are the competition? That's a good point, and I think that has to come through market research. As far as I know, there aren't really many, but of course, if there are, that's a killer. Any other questions?
If anybody is willing to distribute that.
A really good point. So how could we test that?
Ask the possible distributors.
So we could go to ice cream van producers and just say, here's our product. Maybe I can just show them a digital version here and tell them it's sun cream. Would you be willing to put it in for this cost? And they can actually make orders in advance. I don't have to have produced any of this by that time. So I can get all this done before making anything or committing any cost. Another one is, sun protection factor should I choose for my design? I have to make that decision at some point. Do I need different varieties? Or maybe I can decide this by just going down the beach and putting a table out with factor 10, 20, 30, 40, and just giving it away for free, and just seeing how much is used of each. And if it turns out that factor 30 and factor 10 are most used, maybe I need 2 varieties. If it turns out factor 15 is used 500% more than any other one, maybe I just go with factor 15 as my first batch and just sell that. But I can make all of these design decisions before having to invest hugely in any manufacturing or production by simple prototyping, thinking about what do I need to answer my questions. So that's an example of a market prototype. I think I'll leave it there because we're actually out of time now, but it's been a pleasure speaking to you. And if you've got any last questions, I can take one. In which case, please feel free to link to me on LinkedIn. I'd be very interested to hear how you've got on in your competition, and really best of luck to you all. I am, but I tried to tweet to this board earlier, but it didn't work. So maybe they've closed my account. But I'm not very active, to be honest. More active on LinkedIn.
Okay.
Thank you.
Okay, thank you, Thomas. We would like really thank you very much for this. And actually, Estonia has its own Kickstarter as well. And as a little present for you, we have the Ajujaht team who started with Kickstarter with their product for you.
It's called Ajujaht in Estonia, and we were the first project that got funded there.
Ajujaht.
Yeah.
Ajujaht.
Yes.
Okay.
And this is a bag. Actually, it's an iPad sleeve made of decommissioned fire hose.
That's fantastic. Now I can go and buy an iPad. Thanks very much. Cheers. Thank you very much. Cheers. Okay, I guess you can go and get some beer now or something.